Some of you I know, some of you I don't. I'm Andy Miller. In my day job, I'm a professor at UMBC, and I study environmental science, water resources, rivers, floods, and I've had some occasion to get involved in issues related to climate change, partly through the Maryland Climate Change Commission. I was involved in some work on projections about water resources and the future of water resources in Maryland. But that's not really what I'm going to talk about today. I'm going to try to take more of a global view and to give you some idea of what it is that we're facing over the coming centuries. And the world to come, obviously, is sort of a play on traditional view of the afterlife. But I actually am not talking about the afterlife. I mean, quite literally, the world to come. So one way that I can talk about this is to say that there's evidence that's mounting, and I'm going to show you some of it, that we are actually entering a fundamentally different phase of history of life on this planet. I'm going to actually pull this show. I'll put it in perspective for you this way. My dad happily will be celebrating, sorry, Joelle. My dad will be celebrating his 93rd birthday tomorrow. So he was born in 1921. Now there has been dramatic change, of course, in many aspects of life since he was born. For those of you who were in school yesterday, we had a baby naming. Rena Gratz, Ricky and Sarah Gratz's daughter, was named. If she lives to the same age as my father, she will see conditions on this planet that have not existed in the entire history, not only of recorded kids' history, but of the human species. Okay? We're talking about changes that big. So there's lots and lots of information that's come out in various reports issued by different agencies. The Intergovernmental Program on Climate Change issued a big report last fall. The National Climate Assessment by the US government came out just a few weeks ago. Maryland did an update on the sea level rise projections, and I've got various other sources I'm drawing from here. So nothing I'm showing you here is my own research. I've gleaned stuff from a lot of different sources in order to try to give you an overview of what we're talking about. Now, I'm not going to read this slide to you. All I'm showing you is that every slide that's in the introduction to every one of these studies will tell you about the various indicators we can see that are going on right now today in terms of how the world is changing. Clearly, temperature is going up. Clearly, the frequency of storms is changing. We are losing sea ice. We are losing glaciers. We are seeing sea level rise. There's a whole bunch of things going on. Okay, and the cumulative effects of all of that are going to be quite dramatic. So let me start by asking you a question. I'm just curious to see, hear some opinions on this. What % of scientists who do research on climate and its impacts believe that global change is real and that it's a result of human activity?
97.
Okay. So there's always someone in the audience that answers the question the right way before anybody else can get the wrong answer. And we talked about this yesterday, but Mo probably knew it already. That's absolutely correct.
Behind you. Behind you. There's somebody.
Sorry. But in fact, that's not what most of the American public thinks. So the Pew Research Center did a survey in 2014 in January that mimics the results they got from previous surveys in 2009, 2013. Top policy priorities, what priorities should we place on dealing with global warming? It came in number 19 out of 20 in the goal for the American public. And if you ask people what they think about climate change, actually 2/3 of the public thinks that climate change is real and that it's happening. 44% think it's mostly because of human activity, and there's a range of different opinions. And of course, there's a partisan breakdown in this, but I'm not here to talk about the politics of the situation today. Furthermore, few Americans cite global change as a major threat compared to most other places around the world. So it comes out at about 40%, whereas if you look at all countries, it's about 54%. Okay? So Americans are apparently not that worried. They don't see it as an imminent issue. Now, a study that was done recently summarized where this 97% comes from, looking at more than 12,000 papers, and the consensus indeed was more than 97% of scientists said it's real, it's happening, it's due to human activity. But if you ask the public, there's the 97% number. Most of the public thinks that the opinions among scientists range from almost none to a few on the far fringes think it's this high, but most people think that there's a raging controversy about the science. There is none. So I use this cartoon because it kind of summarizes my personal experience. I've been teaching in my introductory environmental science course for about 30 years now. When I started teaching, well, Actually, this is after I started teaching. In 1990, I've been teaching since 1983. But in 1990, we were thinking, well, there might be something going on. We should pay attention to this. And as time has gone on, the evidence has become more and more clear to the point where it's now just an overwhelming cascade of information that all points in the same direction. And you'll notice, as this guy who represents the Intergovernmental Program on Climate Change is saying, sorry to sound like a broken record, we really have checked it, we're not making it up. And the question of whether anybody's listening is certainly one of considerable concern. So I'm going to show you data now, okay? First of all, how many of you are familiar with the concept of the greenhouse effect? Okay, so essentially what it says is that you add more carbon dioxide to the atmosphere, it absorbs long-wave radiation that otherwise would escape the atmosphere, and it acts like a thermal blanket, it heats the climate, okay? So back in the late 1950s, a guy by the name of Keeling had the bright idea of putting up a monitor on the top of the Mauna Loa volcano in Hawaii to track concentrations of carbon dioxide in the global atmosphere. And this is a continuous record that's been going on ever since then. When he started, the concentration of carbon dioxide in the atmosphere was about 315 parts per million, which is not a lot, but it's enough to cause, without carbon dioxide in the atmosphere, the globe would be much colder. Now, just last May, for the first time, we broke 400. As of May 11th, it was not quite 402 parts per million. Now, I want to put this in perspective for you by looking at a range of different time scales, okay? So that's the last 50 plus years. This is the last 300 years. This is that record compared to the last 300 years. So we started at a range somewhere in the high 200s, which appears to have been stable at least over that time, and has gradually started to rise with the Industrial Revolution, combustion of fossil fuels, deforestation, a bunch of other changes. And this is what's been going on. As you can see, that rate is accelerating. This is the last 10,000 years. So the concentration has been mostly fairly steady for most of the last 10,000 years, and this is what's happened in the last 50 years. Actually, not the last 50 years, it's the last couple of hundred years. Okay? I go even farther back because we have trapped atmospheric gas bubbles in Antarctic glaciers in which we can measure the concentration of carbon dioxide. And we know that the concentration of carbon dioxide has varied as we have gone through multiple ice ages in the history of the planet. So 18,000 years ago, they were glaciers over a mile thick, as close to us as central Pennsylvania and northern New Jersey. And at that time, concentration of carbon dioxide in the air was down around 200 or less. But that's happened in every previous glacial episode, and then during what we call interglacial episodes, comparable today, concentration comes up to about 280, but it's never been higher than somewhere between 280 and 300 any time in the last 800,000 years. And in fact, the proxy evidence we have suggests that it's not been as high as it is today since around 3 million years ago, which is the forerunner of anatomically modern humans evolved between 400,000 and 250,000 years ago. So during the entire history of the human species, there's never been carbon dioxide level in the atmosphere comparable to what you have today.
Can you just underscore where we are right now?
This is us now. This line here is 400 parts per million, okay? So this is where we were at the beginning of the Industrial Revolution. This is where we are now. Yes?
But of course, you know, there's 7.2 billion people in the world.
Yes?
2 countries have a billion each.
Yes.
That's kind of the answer to the whole
So I'm not even going to try to get into what we do about it. If you want to listen to Joelle, in the next session she'll be talking
We'll
about
tackle
it.
what we're going to do about it.
I'm just going to present you the scientific evidence because I can't begin to tell you how we're going to deal with it. I have a couple of slides which we may or may not get to talk about it a little bit. So we know there's a strong relationship between carbon dioxide concentration and global temperature, and that global temperature has been increasing pretty steadily and rapidly also over the last several decades compared to what the norm was during much of the previous century. We also know that global climate models do a fairly good job of predicting temperature. And interestingly enough, this solid line is the trace of temperature. This sort of sandy color is what we think the temperature would be if we accounted only for natural factors in the environment. The only way we can simulate what's happening is by including the effects of human activities. And when we do that, we do a fairly good job of simulating, with obviously a fairly large error bar, but of simulating the magnitude of change that's been experienced thus far. So, I'm not going to read this slide, but it simply highlights a number of different things that are impacted by this, because it's not just temperature change that we have to be concerned about. There's a whole host of environmental issues that relate to the impacts on human activity, economic activity, agriculture, water supply, disease, and so forth, that we have to look forward to as concerns that are going to become more and more imminent as time goes on. And we are already seeing increases in things like floods and wildfires, droughts, heat waves, outbreaks of pests. There's a concern about increasing range of tropical disease moving into the mid-latitudes where we live. So everything we're going to show you in the next few slides is not a prediction. It's what's already been measured happening. We'll get to the future in a little bit. So we know that observed changes in very heavy precipitation, which can lead to flooding, particularly in the Northeast, have gone up by about 71% in the last few decades. Various places around the country, that value is less significant, but it's certainly pretty significant in the northern areas. And if we look at the trends in flood magnitude, the vertical triangles show you higher flood frequency in the same places that have had the increase in heavy precipitation. Meanwhile, in the Southwest, they're experiencing greater drought and greater likelihood of shortages in water supply. We're losing ice from Greenland, and we're losing ice from Antarctica. And this has global implications, as I'll show you in a little bit. And in fact, we know that over the last couple of thousand years, sea level has largely been fairly stable relative to where it is today. It's been a little bit higher recently. This is what's been happening in the last half century. And in fact, if you look at the computer model projections based on the emissions scenarios, the IPCC back in the early 90s projected a range of sea level change between here and here. And guess what? We're on the absolute top of that range. So the projections have been conservative compared to what we are now actually observing. We are at the upper end of what the predictions have been. We know that there's drought going on in California now. The estimation is that we're going to see much greater duration and frequency of drought in much of the southwestern U.S. One of the consequences of that is increased incidence of wildfires. There are fires going on in California right now. These are smoke plumes coming off the coast. I don't think these are the current fires, but you can substitute any year now, because every year we get this going on, not just in California, but in other parts of the West as well. This shows you the increase over the last several decades in the amount of acres burned by wildfires in the West. So this is becoming endemic to the West. We're seeing a massive shift in the frequency of these things happening. At the same time, we're seeing expansion in the range of insect pests that can decimate forests. So we're actually losing forest ecosystems, particularly in the Mountain West and up into Canada at an alarming rate. If you go to higher latitudes, places like Alaska, this is from Norway, any place in the Arctic region, there's permafrost under the ground, and it has been frozen for thousands and thousands of years. It is now melting. When it melts, foundations fall apart, structures are undermined, buildings fall down. Okay? There are other consequences as well. And we're seeing increased rates of coastal erosion, largely related to sea level rise and to stored activity. So now we're going to talk about predictions, and I just want to remind you that when we make predictions, most of the model predictions we made today have underestimated. So when people talk about models not being accurate, they're right. Models have a lot of uncertainty associated with them. But the chances that you underestimate the change are just as great. And in fact, because scientists try to be pretty conservative, they've probably erred on the side of being too cautious. So this shows you, if this is, actually we're right here today, about 400 parts per million, and projections, depending on which emission scenario you follow, get us up around 500 parts per million, but the trajectory we're on right now would take us to about 1,000 by the end of this century. The last time we had 1,000 parts per million of carbon dioxide in the atmosphere was 100 million years ago. That's where business as usual would take us if we don't do something. Now, global average surface temperature change, the projections are, the latest projections are, if we adopt a really extreme measures to try to reduce the impacts and to reduce emissions of greenhouse gases, we could find ourselves stabilizing at temperatures that might be within the range between 1 and 2 degrees Celsius higher than what they are now. But the trajectory we're on right now would take us somewhere between 3 and 6 degrees Celsius. Last time temperature was 2 degrees Celsius warmer than in 1900 was 130,000 years ago, when sea level was between 4 and 6 meters higher than it is today. The last time it was 3 degrees Celsius higher, which is a very likely outcome now, was about 30 million years ago. Yes.
I forgot the conversion. What's that mean in Fahrenheit?
So 3 meters is going to be about between, like, right around 11 feet.
11 what?
Around 11, oh, degrees is 1.8, so that's 3 point, it's about not quite 5 degrees Fahrenheit. 3 degrees Celsius is not quite 6 degrees Fahrenheit, like 5.6. 3 times 8. No, not 5. Not 5. And business as usual could take us into a range that has not been seen on the planet in 30 million years. So what can we expect? Obviously, temperatures going up, changing amounts of precipitation, probably more heavy rain and floods, as well as more droughts, sometimes in the same places. Rising sea level, and I'm going to show you some information focusing on that. Changing pH of the oceans. How many of you thought about changing pH of the oceans? If there's anybody in this room that's thought about that issue, I'll be shocked. It was one of the things I learned about a few years ago that absolutely stunned me, and I'll try to explain why if we have the time. Risk of affecting water supply availability, crop yields, disturbance of forest ecosystems, spread of insect pests, and impacts on human health, including the spread of tropical disease vectors. So, hotter summers. So we anticipate within the next 50 to 60 years, the average summer, well, 95% of the time, most summers, almost every summer will be hotter than the 95th percentile of summers now. So if you take the hottest summer you've had, that's going to be the norm. That's not going to be the norm. The hottest summer we've had might be close to the coolest summer in the future. This shows you anticipated changes by the period between 2071 and 2099. You'll notice that everywhere the temperature changes on the order of 6 or 7 degrees Fahrenheit, but the farther north you go, the bigger the change is, so that in the Arctic regions, it could be on the order of 10 to 13 degrees Fahrenheit, which is going to make massive differences in terms of what goes on there. We're also going to see big changes in precipitation, and for the most part, where we live, things are going to get a bit wetter. I will say the good news for Maryland is that if you live anywhere and be least affected by environmental hazards, this is a pretty good place to live. We're not immune, but we're in better shape than some places. But if you live in the desert Southwest, it's bad news, because there are large areas that are going to see much more drought, and that's going to have major implications for them. So global sea level is what I want to focus on for a couple of minutes here. So this is where we are today in terms of sea level rise since about 1700. It's gone up maybe about a foot or two. But this is what the anticipated change is depending upon which emissions scenario we follow. Business as usual could see sea level go up by 3 to 4 feet by the end of this century compared to where it is now. In Maryland, actually, a report that was issued by a commission chaired by Don Bosch, who's the president of the University of Maryland Center for Environmental Science, issued this report last year at this time, and they project that the most likely scenario for Maryland, because locally the land is sinking, so sea level rise a little faster in Maryland than elsewhere, we're likely to see about 3.7 feet of sea level rise by the end of this century. It could be as much as 5.7 under the scenarios they were dealing with. There's new information that has come out since they issued that report that makes things worse. So how many of you remember 2003 Hurricane Isabel? If you live around here, many of us had no power for a week. Some people had no power for a couple of weeks. So this is what was going on in Annapolis at that time. This is what was going on in downtown Baltimore around the Inner Harbor at that time. Now this was a hurricane flood that was not necessarily in any way related to global climate change. It was simply a storm that happened to focus winds up the bay to cause storm surge. The reason I point that out is that if you raise basic sea level by a couple of feet, the frequency of something like this happening becomes much, much greater. So that instead of a rare event, it becomes a commonplace event. And if you think about the amount of real estate surrounding, low-lying areas surrounding the Inner Harbor, and surrounding the bay as a whole, and we're going to get to Miami in a little bit, the amount of real estate that's at risk in this country is huge. If you live in a country like Bangladesh, you're in big, big trouble. So, quick question. Was the flooding in Superstorm Sandy a consequence of global climate change? Has anybody heard speculations about this?
I think it was. They said it's going to be worse.
Mm-hmm.
They were saying this is just a precursor
Mhm.
of what could happen. And even the governor at that time was talking about it.
So there was a lot of discussion of this, and a lot of people have attributed this to global climate change. And it turns out there's been a very vigorous debate about this among climate scientists. And there's one person who actually argues that just as this was maybe affected by that process, the weird winter weather we had this year also may have been part of the consequence of this. You know that while people talked about how cold it was, it's only 2% of the planet that was colder than normal this winter. Most of the planet was warmer than normal. The West Coast had unusually warm and dry conditions. And we were just caught in a very, very peculiar situation, which is a natural phenomenon, but whether it was caused by climate change or not is really a subject of considerable amount of debate. There's a lot of hypotheses floating around on both sides. The jury is still out. Some of the debates have been somewhat involved name calling, which sometimes happens among scientists. But what is clearly true is regardless of whether the storm itself is more likely in the future, which I'm not inclined to say with any degree of confidence is true at this point, it won't take a storm that big to cause coastal flooding on a massive scale if sea level is several feet higher than it is now. So I actually got a phone call from a reporter at The Sun last summer because they were looking at the casino they're building down by the Inner Harbor near the stadium, and he said, well, they redid the flood maps, and it shows that it's not within the 100-year flood zone like it was before, and he wanted to know, was this some kind of a scandal? And I said, no. People redo these maps all the time. I looked at the report. It looked like it was fairly legitimate. And I said to him, he said, are we at risk? I said, well, look at the entire Inner Harbor. Look at how much real estate there is in Harbor East. The casino, yeah, the casino's at risk. So is everything else. We've already bought that. So we're going to have to figure out what to do about all of it, not just one structure. So one thing to keep in mind when we make these projections about 2100 is that's not the end of the story. In fact, even if we end all the emissions now, sea level by 2300 will be up to about, say, 140 centimeters, so that's maybe about between 5 and 6 feet above where it is now. If we stabilize at 2 degrees Celsius, then you've got nearly 3 meters of sea level rise. If we don't, you're talking about maybe 3.5 meters of sea level rise. We're talking about big changes, and the fact is that no matter what we do now, those changes are already in motion. So, what was the most important news item that you heard in the last week? It was not one of the ones that Rabbi Shulman mentioned from the Bima yesterday. This is a news item that shocked me. Perhaps it shouldn't have. But basically what it says is there's a large section of the West Antarctic ice sheet that started to fall apart. People have been predicting for years that there was some possibility it might happen sometime in the future. It's happening right now. And the estimation is that that could cause as much as 10 feet of sea level rise by itself over the next couple of centuries. Okay. I'm going to show you a video that animates this and illustrates what's going on. So just bear with me a moment while I fire it up. This is only about a 2-minute video. Hopefully we'll be able to hear it. I think it's loud.
We are heading towards the particular sector of West Antarctica draining into the Amundsen Sea. This sector is drained by 6 glaciers. The biggest ones are Pine Island Glacier and Thwaites Glacier. The speed of the glaciers measured by satellite is shown in color code. Red is fast, blue is slower, and green is the slowest. The glaciers flow into the sea and form floating extensions called ice shelves. Now in red are the areas where the flow speed is increasing almost every year. The darker the red, the more the glacier has been speeding up. You see that all the glaciers are speeding up. Now we focus our attention on the Smith Glacier, which is a smaller glacier, but which has experienced some of the most dramatic changes. The grounding line of Smith Glacier in 1996 is at the transition boundary between the blue color, the ice shelf, and the white color, ice resting on the mountain. Now we transition to 2011. The grounding line is 35 kilometers farther back.
I need to just say a word about that. The grounding line, so you have these ice shelves that are out floating. Ice floating in the water has no effect on sea level rise. But the ice that's grounded essentially is stuck in place. It's like a plug. When that ice starts to float and breaks off, you take out the plug. When you pull the plug out of your bathroom drain, what happens? Okay, that's what happens to glaciers. Once you pull that plug out, you're going to start to see much faster flux of glacial ice off Antarctica. So that's what they're talking about.
Retreat nearly 2 kilometers per year. If we could peel off the ice from the continent and see the bed, this is what it would look like. The arrows indicate the flow direction of ice, and color indicates the speed. Blue is slow, red is fast. We see that the glaciers flow on top of major subglacial valleys colored in brown. The darker the brown color, the deeper the valleys. As the glaciers retreat, they will follow these deep valleys. There is no mountain or big hill along the way that will act as a barrier to hold these glaciers back. The glaciers speed up, the grounding line retreat, the deep valleys that are sloping inland all reinforce each other to make the retreat of ice in this part of Antarctica unstoppable. And we think that this is what is happening right now.
Better. Okay. So this just shows you a picture of the ice shelf, the sea ice out in front of it. And you've just seen the animation. Now I want to point something out. This is not going to happen anytime soon, okay? But 18,000 years ago, the coastline was about 100 miles east of where Ocean City is today, and Florida, the landmass that is Florida, was more than twice the size that it is today, okay? On the other hand, if you were to take all of the ice sheets on Antarctica, and right now we're only talking about the West Antarctic ice sheet, which is the smaller one. If all of it melted, the coastline would be up here. Memphis would be in water, okay? And everything, so sea level would rise something like 70 meters above where it is today. Now, we're not anticipating anything like that happening anytime soon. The glacier, the ice sheets on Antarctica have been there for 14 million years. But we are anticipating big enough changes that incremental changes, particularly in places obviously that are near the coast, are going to be significant. So I'm going to show you another website that illustrates what will happen in Chesapeake Bay area, and then I'm going to show you what will happen in Florida. So this is basically, it's got a little thing on it that I can switch to show you. This is basically if sea level is close to where it is today. If sea level increases by 10 feet over the course of the next couple of centuries, those are the areas that are going to be underwater. And one of the things you have to think about is that a lot of our infrastructure is very close to sea level. So we're going to have to basically rebuild all of our infrastructure in terms of storm drains, in terms of all kinds of other infrastructure that exists. If we go to Florida, so I would say it's not a huge risk for those of you who are old enough to be thinking about retiring to Florida now, but your children and grandchildren might want to think twice. Let me show you what we anticipate happening in Florida. Here's Miami, here's Fort Lauderdale, Palm Beach, okay? Fort Myers over here, watch this. So if sea level goes up by 4 feet, you have this situation. If it goes up by 7 feet, you have this situation. If it goes up by 10 feet, that's Florida. Okay.
So it's better on the Gulf than the ocean?
Well, it's better if you're at higher elevation. I would not be buying real estate in Florida myself. But if you do buy real estate in Florida, you better hope you get a return on your investment pretty quickly. Your kids are not going to get much of it. Or at least, maybe your kids will, but your grandchildren or their children, maybe not so much. And we can see similar things happening in other places, but Florida is probably as dramatic an example as you'll find, except that we don't have maps like this for other parts of the world where there are actually hundreds of millions of people at risk. So for some parts of the world, this is, you know, I mean, I have a colleague who says, well, it's all right, we'll just adapt. And he's right, the wealthy societies will adapt. The question is what's going to happen everywhere else. There's a lot of people who don't have the capacity to adapt. We're almost out of time, so I'm just going to show you a couple of things really quickly. I mentioned the pH of the oceans. So the pH of the oceans, I'm not going to go through all the chemistry, but the oceans are slightly alkaline. And the oceans are what we call buffered, which means that the chemistry doesn't change, okay? Except if you put a lot of carbon dioxide in the water, it changes the acidity. And it's clearly going down now. And the projection is that it's going down even further by 2100. And it's getting into a range where shells, organisms that secrete shells, actually are going to be unable to form those shells properly. And where, in fact, if we look at what's going on in the global oceans now, these are environments that are adequate to sustain coral reefs. But by 2100, we might have a situation where, in fact, most of the coral reefs in the world are in places where they can't form calcium carbonate skeletons. So you're looking at the destruction and loss of major ecosystems. You're looking at changes in water supply sustainability. This is what it looks like today. This is what it may look like by 2050. You're looking at declines in crop yields. You're looking at changes in forest ecosystems. I'm not going to go through the details of this, except simply to say trees cannot get up and walk. If they're adapted to a certain climate, when that climate changes, if it changes faster than the trees can disperse, you may lose those populations. You're going to have very different forests in the future. And I'm not going to go through the list of these, but we know that there are a number of places around the world where there are potential tipping points in climate that are going to affect the functioning of natural systems in major ways. I'll say one last word before you go. 3 options. Do things to try to prevent this, do things to adapt to conditions that may occur, or just deal with what other consequences are. And in reality, you can't just mitigate because it's too late. You can't just adapt because if you decide not to do anything to mitigate, it's going to get so expensive that you can't adapt fully. So I like this line. This comes from John Holden, who's the White House science advisor. He says, we need enough mitigation to avoid the unmanageable and enough adaptation to manage the unavoidable. So that's my last word for you. And if you want to hear more about things you can do, you can come to Joel's session.